Hi everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be studying progressions lecture 4. So today we'll be talking about AMG Management and related inequalities. So let's start the lecture. Let's first talk about AMG Management for two numbers. So let's talk about AM first. Let's say we have two numbers A and B and we have AM in between. Let's call it as A. So we have A in between, that is the arithmetic mean. Now how is this A is being defined? A plus B by 2. This is how arithmetic mean is being defined, right? Now if we talk about GM, in that case, we can either have two positive numbers or we can have two negative numbers. We cannot have a mix of both. It's not possible to have A as negative and B as positive. It's positive, it's negative and it's positive. This is not possible. Why? Because the way we define GM is under root of AB. So if one is positive and one is negative, then it won't be possible to have a real number over here, right? So we have to fit in a real number between them. So that is why both of them either should be positive or both of them should be negative, right? So in case both A and B are positive, so we'll have under root AB. In case both A and B are negative, then we'll have under root minus of under root AB, right? Why? Because it's a negative number, and it doesn't make sense to have a mean. Either it's a geometric mean or an arithmetic mean. It doesn't make sense to have a mean which is having a different sign as compared to the one surrounding it. Mean is supposed to be in between, somewhere in between, right? And if we have two negative numbers and we are fitting a positive mean in between them, that doesn't make sense practically. So that is why if we have two negative numbers, we have a minus sign over here, and if we have two positive numbers, we have a positive sign over here, right? You can also relate it mathematically. Let's say we have C in between, or let's say G in between. Now with the help of GP condition, we know that G square equals to AB. Now G would be plus minus under root AB. So minus case is for the negative numbers, plus case is for the positive numbers, right? Now let us talk about HM. And as we have studied earlier, whenever we have to talk about harmonic progression, we have to revert back to arithmetic progression, right? Because it's the reverse of that. So let's say three numbers are there. Let's say A, H, and B. These three numbers are in HP. So we have to find out the harmonic mean between them. So basically, that would mean 1 by A, 1 by H, and 1 by B. That would be in arithmetic progression, right? So if these are in arithmetic progression, then we know that 2 times H equals to 1 by A plus 1 by B. So basically, summation of this term and this term would be equal to twice of the middle term. That is the arithmetic mean, right? So that is why we get 2 upon 1 upon A plus 1 upon B equals to H. So this is how harmonic mean is being defined. You can simplify it further. You will get 2AB upon A plus B. So if we have two numbers A and B and we have to find out, so basically we have three numbers A, H and B, and H is the harmonic mean between harmonic mean of A and B. In that case, harmonic mean is defined by 2AB upon A plus B. Now this is the important result. G square equals to H. You can just multiply them and you will see that G square equals to H. This is a very simple result to remember. You can just prove it by multiplying them. Now let's see this example. The AM between two positive numbers exceeds their GM by 5 and GM exceeds their HM by 4. Find the numbers. So let's say we have two numbers A and B. Now if we talk about AM over here, that would be A plus B by 2. And the condition is given that AM exceeds GM by 5. So AM minus GM would be root AB, and that is 5. Similarly, the other equation is GM exceeds HM by 4. So GM would be root AB minus 2AB upon A plus B equals to 4. Now, how to solve these? So first, simple method is to add them, because that would cancel out this root AB term. So let's add them. So that would give me A plus B by 2 minus 2AB upon A plus B equals to 9. So if I cross multiply, then I'll be getting A plus B whole square minus 4AB equals to 18 times A plus B. So this is our first equation. Now one thing I can clearly see that I'm getting A plus B whole square and getting 4AB over here. I'm getting A plus B. Then I have to square any one of them. But I'll prefer doing the first equation because it looks a little less messier, right? So that is why A plus B minus 2 times root AB equals to 10. So A plus B equals minus 10 equals to 2 root AB. And if I square both sides, I'll be getting A plus B whole square plus 100 minus 20 times A plus B equals to 4 times AB. So I'll just do some adjustments over here. I'll be getting a plus b whole square minus 4ab equals to 20 times a plus b minus 100. Now I can see that this term and this term is exactly the same. So I'll use 18 a plus b over here. We'll be getting 20 times a plus b minus 100. So basically I'll be getting, this is 20. I'll be getting a plus b as 50 over here, right? Now if I'm getting a plus b as 50, I'll replace this value over here. So that would become 25. 25 minus 5, that is 20. 20 equals to root ab. So basically ab equals to 400. So I'm getting ab equals to 400 from there. A plus b equals to 50, ab equals to 400. Either way you can do it by quadratic by using a equals to 50 minus b, or you can use the common sense over here and you can clearly see that a equals to 40 and b equals to 10. So a equals to 40 and b equals to 10, and vice versa, b equals to 40 and a equals to 10. So these are the possible solutions for this question. Now let's talk about this example. If a, b, and c are distinct positive integers less than or equal to 10, the arithmetic mean between a and b is 9, the geometric mean between a and c is 6 root 2, then the harmonic mean between b and c is. So let's write the first condition. So we have a plus b by 2 equals to 9. So that means a plus b equals to 18. Now we have been given that all three numbers are distinct positive integers and that are less than 10. So it can be possible only two ways, either a equals to 10, b equals to 8, because both of them cannot be 9 because they are distinct, or the other case would be a equals to 8 and b equals to 10. There is no other possibility. If we make a greater than 10, then that is not a possibility over here because all of them are less than 10. So let's look at the case 1. This is case 2. Let's look at the case 1. So the second condition is under root AC equals to 6 root 2. So basically AC equals to 72. So if I take A equals to 10, then C would be 7.2. That is not possible because all are positive integers. So this case is rejected. So the other case is A equals to 8 and B equals to 10. So if A equals to 8, we'll be getting C equals to 9. So we have got A equals to 8, B equals to 10, and C equals to 9. And we have to find out the harmonic mean between B and C. So that would be 2BC upon B plus C, right? Now let's talk about AMG and HM for n numbers. Now since we have talked about AMG and HM for two numbers, we can generalize it for AMG and HM for n numbers. We won't be proving it, but we'll be generalizing it for n numbers. So for n numbers, let's say we have A1, A2, A3, A4 till AN. In that case, AM would be sigma A1 from n equals to 1 to n equals to n, and divide by n. This is our AM. Similarly, GM would be A1 dot A2 dot A3 till AN raised to power 1 by n. In case of two numbers, it used to be 1 by 2. For n numbers, it's 1 by n. Now, if we talk about HM, then it was 2 upon 1 upon a plus 1 upon b. Similarly, over here, it would be n upon 1 upon a plus 1 upon b. Sorry, 1 upon a1 plus 1 upon a2 plus 1 upon a3 till 1 upon an. So this is how we have defined AM, GM, and HM for n numbers. Now let's talk about AM, GM, and HM inequalities. So again, we'll be demonstrating with the help of two numbers, and then we'll be generalizing it for n numbers. Now let's say we have two positive numbers. Again, the word of caution over here is two positive numbers, right? Two negative numbers or two positive numbers. We won't be talking about one positive number and one negative number. These inequalities are only meant for either both of them are positive and or both of them are negative, right? So now we are considering the case of both of them are positive. So let's find out AM minus GM. So AM would be A plus B by 2 minus GM would be under root AB. Now what I can do, I can write it as root A square plus root B square minus 2 times root AB divided by 2. So this becomes root A minus root B whole square by 2. Now we know that this number is always greater than or equals to 0. Why? Because it's a square and cannot take a negative number. It can be 0 when both A and B are equal. So basically we get to understand this thing that this inequality would become 0 only in the case of when both A and B are equal, and if they are not equal, then it's always greater than 0, right? So AM equals to GM only when both the numbers are equal, and AM is greater than GM always when both numbers are not equal but positive, right? Let's look at the other equality, GM and HM. So let's calculate GM minus HM. Again, we are taking two positive numbers. So GM would be root AB and HM would be 2AB upon A plus B. So what I'll do, I'll take root AB as common. So this would become A plus B minus 2 times root AB divided by A plus B. Now this number is positive because we are talking about GM of two positive numbers. This number is also positive, and this the numerator again becomes root AB upon A plus B times root A minus root B whole square. This number is positive. This number is always greater than or equals to 0. So basically again, GM is always greater than or equals to HM. And in the previous inequality we got AM is always greater than or equals to GM. Now the equality holds when both the numbers are same. In that case, AM equals to GM equals to HM. Only when both the numbers are same. Now in case of negative numbers, both of them are negative. In that case, AM is less than or equals to GM, GM is less than or equals to HM, and AM is less than or equals to GM is less than or equals to HM. But both the numbers should be negative. So in case of positive numbers, the inequality would be the other ways. In case of negative numbers, the inequality would be in this manner. Now let's look at this question. If L, M, N are the three positive numbers, three positive roots of the equation x cube minus ax square plus bx minus 48 equals to 0, then the minimum value of L by 1 by L plus 2 by M plus 3 by N equals to. Now, as of now, we are studying AMG inequality. We can see that, okay, we have to apply AMG inequality over here. But in case of examination, what should be the trigger in our mind based on which we can say that, okay, we have to use AMG inequality in this question. So the trigger should be, you should be seeing minimum value of a summation or maximum value of a product. If you see this kind of language, or if you see this kind of language, then basically you have to use AMGM inequality in most of the cases, right? Exceptions will be there, but in most of the cases, this would work. So let's look at over here. So we have to find the minimum value of this. So 1 by L plus 2 by M plus 3 by N. So if I apply AMGM inequality, I'll be getting divide by 3 greater than or equals to 1 by L dot 2 by M dot 3 by N raised to power 1 by 3. Now one more thing, why don't we use AM-HM inequality or HM-GM inequality? Why not we using that? Because over here, this is summation of root. If we go by the theory of equations, A is the summation of roots, right? And that is an unknown number. This one B, that is summation of roots taken two at a time. That kind of equation comes when we use the HM inequality, but in that case, this number is unknown, so we won't be using any inequality, that will be using HM. But this one is known product, so we have to use AM greater than or equals to GM, that kind of inequality, right? So that is also giving us trigger that we have to use AM GM inequality. So L dot M dot N equals to 48 from theory of equations. So we'll be getting 1 by L plus 2 by M plus 3 by N greater than or equals to 3 times. This would become 6 upon 48 raised to power 1 by 3. So this is 1 by 8. 1 by 8 raised to 1 by 3 would be 1 by 2. So that would be 3 by 2. So 3 by 2 is the correct answer. Now let's talk about minimum value of B plus C divided by A plus C plus A divided by B plus A plus B divided by C for real positive numbers A, B, C. So we have to find out the value of B plus C by A plus C plus A by B plus A plus B by C. Now I can clearly see that we have to, whenever we are talking about minimum value and a summation, I can clearly see that we have to use some kind of inequality. We'll see if we are using AMGM or AMHM or GMHM inequality. We'll see that what to use. But this this trigger word minimum value of a summation is giving us the hint that we have to use the AMGM inequalities, right? Now one common thing we can observe over here is in the numerator we have one number. The numerator is one number shy from becoming A plus B plus C, and every numerator is like that only, and that number is present in the denominator. So what if I add one positive number over here, that is plus 1 plus 1 plus 1, and do a minus 3 over here? So that won't hurt this inequality, because we are adding a positive number. We cannot subtract from here because that might make this number negative, but we can definitely add a positive number, right? So in that case, that would become a plus b plus c by a plus a plus b plus c by b plus a plus b plus c by c minus 3. Now what I can do, I can take a plus b plus c as common. That would give me 1 upon a plus 1 upon b plus 1 upon c. Now why this thought came into my mind to take a plus b plus c as common? Because I can clearly see the application of AM HM inequality over there, right? So in this case, if we talk about a, b and c and apply the AM HM inequality, I'll be getting a plus b plus c divided by 3 is greater than equals to 3 divided by 1 upon a plus 1 upon b plus 1 upon c. If I cross multiply, I'll be getting a plus b plus, I'll be getting this product only, and that is greater than equals to 9. Now this is greater than equals to 9, but we had to find out with a summation of minus 3 with this one, right? So that is why the answer is 6. So the modified version was greater than equals to 9. So but we actually made that modified version by subtracting minus 3, subtracting 3 basically, and that is why 9 minus 3 is the answer, that is 6. Now the problem with these questions is these look like very counterintuitive initially, and you might be thinking that how can I get such ideas in the examination? But the thing is, initially they might sound very counterintuitive, the theory and the application might sound very counterintuitive, but after practice you'll get that kind of intuition. So nothing to be worried about that, right? So today's lecture was till here only, and tomorrow is the last lecture of progressions, and let's meet tomorrow. Thanks for watching.